Since we are in the subject of pressure, there is one more thing which is a very important and common thing called atmospheric pressure. Yes, you have heard about atmospheric pressure in a lot of cases. Now let's try to understand what is atmospheric pressure. Alright? Now atmospheric, see you know that atmosphere is what layer of air is around the earth, right? Then we have around 5 or 6 layers of air which surrounds us. Alright? Now the entire thing is what we call as atmosphere. Now think about it. There is 5 layers of air which is surrounding us. Don't you think they are going to put a lot of pressure on us? Because Earth is pulling, the Earth is being, Earth has a lot of gravity. Earth pulls down the air, isn't it? When it is pulling it down, it exerts some pressure. That is atmospheric pressure. Okay? Very easy to understand this one. Atmospheric pressure. And we feel atmospheric pressure also all the time. But let's try to define atmospheric pressure. Okay, now how do we do this atmospheric pressure is? Imagine you have a vertical column, a huge column, glass column. Okay, it has unit cross-sectional area. What you do? This unit cross-sectional area vertical column from the point to the top of the atmosphere. We are going to take this vertical column. Whatever the weight of the column is, that is called as atmospheric pressure. Understood? That is what we call as atmospheric pressure. So, since you know that this is atmospheric pressure, in layman terms, if we have to understand what is atmospheric pressure, okay, say you are going to calculate the atmospheric pressure at sea level. Okay, so you take a vertical column. Okay, you keep one end of the column on the beach, and another end of the column, you are going to take it to the edge of the atmosphere. Alright? Now, when you take the vertical column, it has some weight, correct? That weight is basically the atmospheric pressure. Okay, the pressure applied by the atmosphere. Alright, this is we are talking on sea level. If I do the same thing on top of a mountain, that becomes the pressure at the top of the mountain, atmospheric pressure. Alright, this is how we calculate atmospheric pressure. Understood? Now what happens? The surface is the bottom of the atmosphere, correct? Like surface you have, on top of it you have troposphere and stratosphere, like you have different spheres, isn't it? Since surface is at the bottom part or the bottommost layer of the atmosphere, the pressure is going to be maximum on the surface. But as we go on increasing in the altitude, the pressure starts to reduce. Okay, the pressure decreases. Now at sea level, this is very important. At sea level, the atmospheric pressure, we write it as 1 atm. We just call it as atmosphere. 1 atmospheric pressure is 1.013 into 10 to the power of 5 Pascal. So much of pressure is being applied on us at every second. Every second we have around 10 power 5 Pascal of pressure acting on us. Okay, now this can be easily understood. Because very simple thing is, take a can, like a Coke can or something like that. Alright, now if you remove everything, like, if you are going to make it as vacuum, immediately the can is going to get crushed. That is because of the atmospheric pressure. The atmospheric pressure is so high that it can crush a metal can. Okay? So, atmospheric pressure is around 1.013 into 10 to the power of 5 Pascal. And remember, the atmospheric pressure keeps on reducing as you go higher and higher at the altitude. See, we just discussed about atmospheric pressure. Now, it's not very practical to keep a vertical column from the surface to the top of the atmosphere, isn't it? To the edge of atmosphere. It's not at all practical. So, is there any experiment where we can calibrate the atmospheric pressure without doing all the circus of having a vertical column of 400, 300 kilometers? Correct? We have to have a practical use of it, or a practical demonstration has to be correct. Now, this is where the torch experiment is going to come. Now, what it is, you will be learning in the next.